Okay, so our recording is started and we should be in pretty good shape here. So let me just take a second to thank everybody for joining us on this seminar that we'll be covering. Today's content is going to be what I call Commonality of Programming. And basically what we mean by that is we're going to talk about 4 different ways for you to actually methodize or create a part program within the Siemens control. As you see here on the screen, ShopMill, ProgramGuide, CAD/CAM, and our FANUC ISO style programming. And we're going to take a simple job. We're going to actually methodize it through all 4 ways and really start to show you how similar every side of the control is and how you can kind of, once you learn the basics of the control, bounce between the different operating modes. I am your presenter, Chris Pollack. I'm a dealer support specialist on the East Coast for Siemens, and I'm always available for anybody for further questions or assistance. Here's my contact info. If you received the email blast, you would have gotten it as well, but feel free to reach out to me anytime with any questions anybody may have. Okay. So our online seminars, we've had a few now over the last few months, and this is a program we're going to continue on promoting in the U.S. Basically, the initiative, I'm trying to do a seminar probably about every 6 weeks or so. You know, obviously, we have to juggle it with whatever's going on in the industry or holidays and whatnot. So here, just to give you a little bit of a forecasting on what's coming up. Beginning of February, we'll be presenting an 808D milling workshop, specifically looking on working with the 808D from a CAD/CAM side of the system, as well as looking at the high-speed functionality in the control. After that, in March, we're going to be getting into G-code-specific programming for turning, and then looks like probably beginning of May we're going to be doing a G-code class specifically on milling. All the webinars can be viewed or promoted at a later date from our CNC4U website. We gave you not only the main website link, which is your usasiemens.com/CNC4U, you can get to the page or the sub-page of the webinars either by going to that link and hitting a sub-link, or you can physically just use the website directly on this, that /CNC4U-webinars. So all webinars, once hosted, will be posted on this website, so you can view the recordings. You can also register for the next up-and-coming webinar on this site. Feel free to pass this around, let customers know, friends know. Anybody is certainly welcome to come and join in the webinar sessions. So today we're going to be specifically talking about content that applies to the 828 control and the 840 control. So everything we look at here, some features may be an option or standard or builder specific, but they're available on either of the platforms. So anything we talk about can be used and leveraged on either the 828 or the 840 controls. Just a quick overview. So our Operate Commonality of Programming is intended to show you how similar functionality is between our ShopMill, GCode, ProgramGuide mode, importing programs from CAD/CAM, or running programs that maybe were previously created for an ISO-style controls. And under the primary topics, we see here we're going to go in and program and simulate a simple ShopMill program. Then we're going to look at it when we're programming it through our ProgramGuide or our Siemens-style G-code. Then we're going to import a program that was previously posted from a CAD/CAM system, and then we'll do the same thing, importing it something that was created for an ISO type of protocol, traditionally more like your FANUC-style programming. So we'll get to see, and all 4 programs are the same job, so it's all identical. So this is the part we're going to work with. I didn't want to give anything too complicated because here we're really concentrating on the fundamental steps. So what we're going to do is we're going to profile this part, so it gives us a chance to just do in a regular shape. We're going to profile and just put a couple holes in the part. Nothing too fancy, but then obviously methodizing it through all 4 different scenarios. First thing we're going to look at is our Program Manager area. We're not going to get an option or an opportunity to get into jog or setup too much on this session because we have a lot of programming to cover. I have covered some basics of setup and jogging and, offset table and whatnot in some previous webinars, so you can certainly, if you haven't seen them, you can refer to the previous webinars. And in the future, I'm going to look to create one that's very specific on all of the tools from setup features that we have within the Siemens control. So what we're going to do here is primarily get right into the Program Manager area as we start. We're going to be using our SINUTrain software, which is our PC emulator. We're going to come in, we're going to navigate to the Program Manager. We're going to look at some of the layout and features. We're going to look at directory structure, how do I start to create programs, so maybe some of the other tools within Program Manager, like saving my setup data. And then from there, we'll transition and start creating our first program, which will be ShopMill. This will probably be a review to a lot of people on this because we have covered some ShopMill programming sessions in the past. The big trick here is I want it to be fresh in everybody's mind as far as the fundamental structure of ShopMill. So then when we apply it to the GCode side, you can see how similar and what's different and what's similar between the two. So we'll go through, we'll create a basic ShopMill program, create a simple contour. We'll get a chance to look at graphics real quick, simulating that job. Different methods of using our simulation, and then even go and jump over to an auto mode. Once we get all that done, then we'll go back and we'll do it in the other three modes. So at this point, without further ado, we're going to switch over to our live presentation section. So give me 1 second here. I need to just share my simulator. All right. So everybody should see our machine tool control now up. This is SINUTrain, so this is a machine tool emulator. I also want to just share the print so everybody has it in front of them. Give me 1 second. All right, so it might be a little hard for you guys to see, but I wanted it there at least for your own reference so you can kind of keep an eye on what we're trying to do. So there's going to be our part print that we're going to start methodizing. So right now, I first power up, or I first come into SINUTrain. I am sitting in a jog mode. I know that because the upper left-hand corner does say jog right here next to my machine button. You can see my cursor hovering around it. As well, my jog button is highlighted. And traditionally, that's usually the first screen you see whenever you power up the control. We're going to jump right over to Program Manager. So I'm either going to use the hard Program Manager button here to the right side of the screen, just below Machine. Or if you hit the menu select key on your front panel, and that's usually located a number of different places on our different front panel scenarios, but when you hit menu select, you will also get a soft button that does the exact same thing. So basically this little keypad I see to my upper right hand corner, we have software keys that match these physical hard keys. So the Program Manager here is the same as hitting the hard Program Manager button. Same thing with alarm, the shortcut program, offsets. Sometimes we change the label name, like you'll notice parameters, which is the second button to the lower left-hand corner of my screen. If I look at the hard key, it's called offsets, same function. Specifically look at the icon. The icon's identical, it's going to the same place. Okay, so we're going to select Program Manager. We're going to come in and we're going to take a quick look at the navigation of Program Manager and kind of how this whole thing works. So when I first pop in, I'm usually sitting on my NC area. So I see in the lower left-hand corner, the button is blue, it says NC, and I see some folders that are pre-created for me. NC is really system memory, for lack of a better term, like RAM. So this would be part programs sitting directly in NC memory. From there, you have a couple folders where you can start to create programs. I could do simple part programs, and those are programs with a .mpf extension. MPF stands for main program file. Could be sitting in this directory. I can create subprograms, and subprograms would have a .spf extension for subprogram file, and they could be sitting under the subprograms folder. Or under work pieces, I can start creating different subprogram folders. So here you see I created a subprogram folder, or maybe I had a few different examples of what I was going to do today, or a temp folder, so you can start building your own subfolders. Now as well, if you have the extended memory option on the control, you'll get a local drive button. The local drive gives you an expanded part program memory, and that memory, depending on the variant of the control, is either sitting on the internal CF card on the system or a hard drive, depending on the machine configuration. But this would be an expanded memory. It's not sitting in RAM per se. So here I could certainly create subfolders, start to create my programs, do what I have to do right within the local drive area. The systems all come with at least a USB port, so you'll always see the USB button. Physically plug in a USB stick to the front of the control, you'll see the button will go black, and then you can access that USB. We treat a USB no different than any other drive, so you can edit files that are on it, you can actually run files from it, you can then obviously transfer programs in and out, and you'll see a little bit of transferring programs when we get to some later examples from my logical drive or my local drive button. We don't suggest making a regular habit to always run from USB, just because inherently USB connections aren't the greatest. It's, you know, 5 little spring clips that are holding those pins in place. But you can, if you get in a bind, you need extra memory space, maybe the file's too large to fit on the machine, you can absolutely run from the USB stick. And then from a networking standpoint, usually a network will show up kind of like this local drive button you see here in the middle of my screen. So in this case, this is a mapped directory on my PC. If this was the machine tools control, most likely this would say network drive, and then I could physically go over. And when I start to look at how do I move programs back and forth, simple folder structure like we might be used to in a Windows environment. So here I created a little area where I have some files. These are 2 of the files we're going to use later down the road, so I'm going to copy them in. These are the originals, and we'll modify them up for the CAM portion of the example and also the GCode ISO portion of the example. So if I want to move files between either USB, network, it's all going to be the same process. Highlight the file. I can highlight multiples by clicking my Mark button. Once they're highlighted, select Copy. Go to where you want to put them. So in this case, I'm just going to put them in my part programs and literally hit Paste. It's that simple. I just transferred over those 2 programs. If I hit cut, it would have obviously cut them and then pasted them here. They still exist on my network or other alternate folder. I just transferred them into the control. As well, if you expand with the double arrow vertical soft key here under cut, you get some additional functions. So things I can do here is I can create archives or backups of the system. If I'm sitting down in a folder area, I can create, under the Save Setup Data, backups of my tool table. So this would be my entire offset table. So I can say, hey, I want to make a file that's going to be a backup of my tool library and all of my work coordinates, and then call it whatever I want to call it. In this case, it gives me a default name. Say OK, and the system will build a file. Now, it did have to be done in a subfolder, because when you do this step, it actually creates a .ini file. I can't do that up in part programs. That's why the button actually is grayed out, because part programs only allow MPF files. When I get to my folder area, I can do all kinds of different protocols of files. INI, you can bring PDFs in here if you wanted to have part prints here, all sorts of different formats. But that's why I did need to create this file right here in a subfolder. Okay, so what we're going to do is we're going to write a new program, conversationally first. So I want to go to the area I want to write the programs in. Doesn't matter where my highlight is within part programs in this case. Select New. Pick the type of program I'm going to write. Now, ShopMill is an option, so not all controls will have it, but it can absolutely be added to all controls. So ShopMill is our conversational portion of the control. It's really up to the builder if they want to make it a standard feature or leave it as an option. So you select ShopMill. You type in a name. We support up to 24 characters, uppercase, lowercase, underscores, just no special characters. So I'm going to call this sample 1. I can use an underscore 1. I keep going out as many places. I got 24 places here. Type in the name, select OK. System's automatically going to launch creating a part program for me. So this is the first screen that I always see whenever I create a conversational program. This is what we call our header page. So the header page, I select a bunch of standard modal functionality that would apply to the whole program. What work coordinate am I using? We do support up to 100 frame shifts or work coordinates. What is the blank? The blank is basically what is my stock going to look like for my graphics. So is it a cylinder? Is it a pipe? Is it a simple block with the middle being 0, 0? Is it some block where I'm going to define two opposing corners? Is it some type of hex stock? So that's all that is. So in this case, I'm going to do a simple block. I'm going to use these dimensions to then define what the overall blank is. So if I look at the part print, I'm going to treat the upper left-hand corner of this part to be 0, 0. So that means that all dimensions of the part are in the plus in X and in the minus in Y. If I want to show a little bit of stock to the left of 0, 0 when I'm first roughing it out, that may be why I would put, like in this case, negative 0.125, give an eighth of an inch. You can also type fractions in here, and it will calculate it to a decimal equivalent. So I'm telling it that I'm starting an eighth of an inch off my upper left-hand 0. The lower right-hand corner, I'm telling it 4 1/8 over, so I'm giving another eighth inch of stock there. And down 3 1/8 on the bottom, because this bottom edge of the part's 3 inch. And let's say the overall thickness, the part finishes at a 1/2 inch. I'll say that the blank is 3/4 of an inch thick. Retract plane, where do I want to go when I'm done with a given cycle or at the end of the program? Safety distance, how close do I get to the part before I start feeding? So it's saying that I'm going to start a 1/100th away from any surface I'm tending to machine to, and that's where it's going to feed from. Down cut or up cut will represent climb milling or conventional milling. So climb milling is down cut. And then if I'm drilling, I can use optimize or always retract to my retract plane, which in this case would be 5 inches. So we want to let it come up to the safety distance and only go to the retract plane when I'm done. Fill out the page, you hit accept, we get our first event of our conversational. And now we're just going to build events as we go. So from here, I want to mill this profile or this shape. So I'm just going to jump over to Contour Mill. I'm going to select New Contour first in the upper right-hand corner of the screen, and then describe my shape. Basically, the way this works is define the shape with New Contour, and then associate it with some kind of operation, like path milling, pocketing, spigot, which is boss milling. So these are the different cycles I can use here. So I'm going to go to New Contour, give it a name. I'm going to call it the, I don't know, outside for my part. Type in a name for your own reference, hit accept, and now we're in the Contour Editor. So this allows me to draw the shape. So if I want to just simply start at 0, 0, upper left-hand corner of the part, I can hit accept. Now I use my icons to start to draw my shape. So in this case, I'm moving over to an X of 2 inches and saving it. I want to now come around this 1.5 inch radius arc. So I'm going to use an arc event. In arc, I want to define the direction, the radius, which I said was 1.5 inches. If I know the endpoint, which I was given it, I'm going to tell it. So I have an endpoint of 3.250, coming down a negative 0.671. Once you fill it out, if there's enough information, it'll show you the result. Now in this case, since I hadn't stipulated the center, it says there's 2 possible solutions to this scenario. And I just hit my dialog select until I make whichever arc I want orange. So I want the smaller of the 2 arcs. So that's why I'm going to select this one, and you'll see the little arc is now orange. Dialog accept again. One final accept. Now I have my first line, my first arc. And now we're just going to maneuver around the part. So I hit the X for doing an angular move. I know I'm coming out to 4 inches, down to 1.802 based on my print. From there, I'm going to go down to the lower right-hand corner, which is a Y of -3. We have a transition function. So if I happen to have a radius or a chamfer at the end of that move, which in this case I do, 1/2 inch, I can tell it. Now it hasn't done the chamfer yet until I put in the next move. So my next move is coming down to this lower corner of +1 inch in X. I don't have any transitions at the end, so I hit accept, and now I see the chamfer come in play. I see my move across. Now I'm going to do a bidirectional move back to x of 0 and a y of negative 1.5. Accept it. Now I need to do my final move up to 0, so I can either do a vertical move up, or if you hit your double arrow button here, just below the arc, we also have a shortcut that says close contour, and that'll just immediately put you back to the start. What had happened here, well, as I built each of these elements or lines, it built up this tree on the left-hand side. So you can actually start to maneuver with your blue arrows up and down the tree if you needed to make any editing changes on any of these events or shapes. So you fill out the shape, you hit accept, shape gets linked into the program, and now I need to just associate it with an operation. So you have 3 primary operations here. I can path mill, which is profiling, which we're going to do in a sec. I can a regular pocket, so if this shape happened to be in a pocket, I could link it to this, or I could link it to our spigot or our boss milling cycle. So this would machine up the shape. So like if you look here, you'd see where in the animated element, the cutter would start clearing all the material until I leave that boss standing. In our example, we're just simply profiling, so I'm going to hit path mill, and we're going to start to fill out the page. So first thing it asks me, tool information right here. So I'm going to go to select tool. I'm going to look at my tool table. Now I don't have any tools created for me. I didn't cheat yet, so we're going to go build some tools. So I come all the way back into my tool table. I'm going to, in this case, on this machine, it's commissioned to only allow tools to be created in an unloaded state. Depends on the machine builder. They can do it either in the carousel or unloaded, and then you go through a loading mechanism. So in this case, I'm creating an 1.25" end mill. So I'm going to pick an end mill. I'm going to type in my name. And when you create names of the tools, you can get pretty creative. So 1.25" mill, we'll call it. I don't need the H offset yet. We'll talk about that when we get to the ISO mode. I'm just going to put a simple length. Obviously, that'll get set when I really touch off the tool. Type in my diameter for my cutter comp and my number of flutes. So I build the tool. If I wanted to right now, I could even load it and give it some location. And then that would move the tool up to this area. Now it's loaded in the magazine. It's ready for me to use. I can hit the to program button in the upper right-hand corner, and it'll even fill out the tool for me right here in the tool table, or in the event of the path milling. Next question is my feed rate. I can program in either inches per minute or feed per tooth if I wanted to. We're going to program in inches per minute. We'll just do a simple 50 inches a minute at 2,500 RPM should be fine. We're going to rough out the part. That's what the little diamond means, rough or finish or chamfering. I could do chamfering in this mode too. Forward means follow the direction I just throw the contour in, or we can say go the opposite direction. I define my cutter comp left, cutter comp right, no cutter comp at all, like an O-ring groove, and then basically the shape parameters in Z. Top of my part being 0. I'm machining a 1/2 inch deep. Make sure that I'm in absolute. You could certainly hit the select key and toggle between absolute or incremental. DZ is my depth per pass, so I'm going to take 250, so this will do 2 shots. Whenever you see a U, UZ or UXY, it's finish amount. How do I want to enter the part? So I'm going to enter either with a quarter circle, semicircle, straight move. We'll just do a simple quarter circle. 1/2 inch radius. Feed rate will come down. How do I pull off the part? What's the radius of the pull off? And what do I do between each pass? Between each pass, I can do no retract, retract to the retract plane, which would be 5 inches above, back to the safety distance. Here, you know, this is a scenario where if I know that I'm going back to where I started from, I don't need any retract. If maybe I have a clamp in the way, maybe we didn't do a full 360 degrees around the part, then I want to pay attention to this field. Hit accept, we get our path mill stipulated. So we've profiled it. Now we're just going to go in and put a quick bolt hole pattern into the part, and we'll then simulate simulate the scenario, and then we can move on and start to look at how I would methodize this in a G-code scenario. Okay, so we'll just jump over to drilling, come to a basic drilling reaming. We've got to go build a tool real quick. All right, so I'm going to create a new tool. This is going to be a drill. I'm going to say this is a 1/4 inch drill. Put a simple base offset here. Diameter, angle of the drill. System will can compensate for that, and we'll see that here in a sec. I'm going to even go and load it. Put it in pocket 6, should be fine. So now I come up. There's my drill. Put it in my program. I can define my feed rate. This can certainly be either feed per rev or inches per minute. Same thing with my RPM, can be straight RPM or constant surface speed. We had the same option before. I can do my positioning based on my shank or my tip. Overall drilling depth, so I'm going to go 750. So it's going to go 750 plus the projected distance of the tip. And do I want to dwell between each hole? From there, I select accept. I get the same little bracket, just like I had before in Contour, because I need to link it to something. In this case, I'm going to link it to my position pattern. So when you go to position pattern, I can do random locations, arrays of holes, or both hole patterns. We're going to do random locations. And then I define my 4 positions. So in this case, they were predefined from the last time I had filled them out in this event. So I have 5/8 over 5/8 down for my first coordinate. Then I'm moving straight over to 2.125 to my next hole to the right. Then I'm going to a value of 1.5 in X, negative 2.375 to the lower hole, and doing a final position move over an X to the final. Do I need the Y? Not if I'm not moving. I could put the Y again, but if I'm moving straight over, I can leave it blank. So you fill out the coordinates for the holes, hit accept. If you have more than the 9 holes that were allowed on the page, you just keep linking those pages over and over again. So you can link as many as you want. So this would be a simple methodized part in ShopMill. So if we simulate it, we take a quick look. We should see an end mill roll around the part, 2 cuts in Z, and we drilled our holes. I can look at it by hitting 3D, look at it 3-dimensionally. You can simulate it in 3 dimensions. So I can start to move it around while it's real-time simulation. You can go into details and zoom in or out, so all kinds of things. There's a cut view if you want to do sectional views. But basically, so we see here that we've just methodized the part in conversational. So from there, if I jump out, next logical step would be simply go over to execute. So you could jump over to execute and then run this part. And this would be cycle start, step through. I see the conversational field. You know, here we're running. I can bring up basic blocks if I want to see the G-code result. This is all traditional conversational. So the next step is going to be how do we methodize it in G-code. So if you give me a second here. So if we jump back over to our PowerPoint. All right. Give me 1 second. Sorry, guys. All right. So the next step that we want to do is we now want to take that simple part that you saw, and I want to show you what's the same, what's different when we get to the program guide area and kind of how program guide works within our control. So we're going to go into the editor. We're going to go in and look at some cycle support with our CAN cycles. We'll create a profile. I'm not going to bother drawing the profile because you just saw it, but I'm going to show you how even there's commonality between the 2 sides of the control. Then we'll just simulate it real quick. And then we'll spend a couple minutes talking about some of the differences when I get to the run mode, because there's a couple nuanced differences when it comes to starting programs in the middle, midstream, and whatnot. Okay. So if we jump back over to our simulator. We can start to look at the same process, but if it was being done in the program guide or G-code. So there are two ways to create G-codes in the control. One is our standard Siemens, what's more of a DIN protocol G-code format, or you could do what we call ISO mode, which would be your FANUC style compatible. We are going to first methodize this part in the Siemens style code. So I come back to Part Programs, select New, and now I'm going to pick the Program Guide radial button as opposed to the ShopMill. And I'm just going to call this Sample 2. So type in a name. Now you notice there's no trigger here. I mean, it's being done in the background. So when I hit OK, it's automatically going to put me into our editor. This is a standard GCode editor. If you go back out, there's nothing telling you here that one was written in G-code, one was written in conversational. You have to physically open up the file to see what it gets launched, if it gets launched in conversational or if it gets launched in G-code. You'll think that the screens even look very similar, especially once before I have put up any text. This is just a simple text editor now. So when you're writing a G-code, very traditional, you do like I say, start, header style, start. So this would be, maybe I want to tell the machine I'm G90, I'm in an absolute mode. G17, I'm in a, that's my orientation of my tool. G54 is my work coordinate. G70 or G700, both in our world stipulating inch mode. So you can start to build up. So a lot of the stuff you're seeing here, this was all taken care of in that first header screen of the program. So that's fundamentally, that's one of the big differences because you don't have a header here. So you'll have to break out. Also, the CAN cycle level, you'll notice that we don't do tool changes there. So you have to do tool changes as independent of the cycles, more of your traditional G-code kind of format. So if I want to do a tool change right now in G-code, I can either type the tool name, or I can use the Select Tool button. It's in the upper right-hand corner while I'm highlighting the Editor button. So if I highlight a different area, I do have to go back to Editor to get to my Select Tool button. I hit the Select Tool function, and then it brings me over to the tool library. Okay. So from there, I can now pick whichever tool I'm going to use first. So I'm going to use my 1¼ end mill, highlight it, and just say OK. And what that does is that automatically builds you what the tool change protocol is going to look like in G-code. So the way it works in our system is if you're using a verbally named tool, like we have here, some long name, it's a T equals, and then within the quotation marks, the name of the tool. And this could be any number of names that you want. Then you want to give it an M6 to initiate the tool change, and I like to always give it my D1, calling up my cutting edge 1. We don't have probably not a lot of time to go into multiple cutting edges, but the system allows you to build up to 9 unique offsets for every tool you create, and you would toggle between them with a D number. So D1 through D9. So generally, if you have only one offset created for a given tool, it's always going to be D1. If you don't put the D1, most builders commission their machines to assume D1, but you do have to make sure that that's how the builder integrated the machine control on his machine. Okay, so the system just did a tool change for us. Now maybe I want to fire up my spindle, let's say. So we'll give it some S code. We were running 2500 just like before. Give it a direction, in this case M3, M4, clockwise, counterclockwise. Maybe I want to initiate coolant, M8. I can turn that on now. Very common, I might want to tell it I'm in an inch per minute mode, feed per minute. G94, G95 would be feed per rev, and some feed rate. So we were running 50 inches a minute before. So a lot of this stuff you'll see was handled in a couple different events of ShopMill. Now we have to just break them out a little bit. Then from there, I'm ready to start telling it to do something. So, maybe I want to do a rapid move. So, maybe we'll get into like a preparatory position. I can do a quick little G0. Maybe I want to go to X -1, Y1, and a Z of 0.1. I don't need spaces. I like to get into the habit of using spaces because when you get to more advanced commands in our control, we have a lot of verbal instructions. You'll see one a little later called Supa, and in those you have to use spaces. So it's just a good habit to get into. We don't need trailing decimals or anything like that or leading zeros. You can put them if you want. Okay, so we got a cutter. It's in our spindle. We position it somewhere close to the part. Now we're ready to profile like we just profiled before. So when you get to the G-code side, you still have contour mill like you saw before. You can create contours right here. But what's a little different is what you're going to do is you're going to create the contours after an end of program, M30. So all contour shapes get built after M30s and then called up when it's time to use them with a call statement. So you're going to get to see that whole mechanism. So basically the way it would work is usually I'll just, if I'm ready to build my contour, put an M30 in real quick and then go into contour under contour mill, new contour, give it some name, and then it launches the contour editor. And now I would do exactly what you saw before. I would do each of those events with the same editor. I'm not going to do that though. What I'm going to do is I'm going to show you how you can now start to kind of drag and drop things between conversational programs and G-code programs. So even something like this contour editor. Now one of the neat functions in our control is we have the ability under edit, if I hit my expand vertical soft keys, I can open up with the open further programs button multiple part programs and view them simultaneously. So here, voila, I have both my conversational program on the right side of the screen and my G-code program I'm methodizing right now. So if you find a lot of common operations, even if you're jumping between G-code and conversational, you can move them back and forth. You can apply them different ways. You can do G-code instructions in the middle of conversational if you want to. We can do that too. So in this case, I want to use this contour. I don't want to rewrite the whole contour. So I can highlight the contour. I'm going to get back to my copy command. I'm going to move over, and I still want to place it under my M30, and I'm going to hit paste. And I just inserted that shape without having to recreate it. With the highlight anywhere within all of these events, if I just use my blue arrow to the right, I can edit it. There's my contour shape. So it's the same exact tool in either area for building contours. And in fact, as you see, you can copy and paste and move between the two. Traditionally on most machine tools, if you don't have a mouse, how do I bounce between these two panes or windows? We have a button called Next Window. You'll see it right by my blue arrows. And you notice as I flip it, the highlight moves back and forth between the two parts. Okay, so now we're bouncing back and forth. So we just really quickly were able to put in the contour shape. Now I want to close that program. So I have a contour, but when it's time to actually use it, back up in the main section of the program above M30, the way it works is under contour mill and under contour, I have to use the call contour function. And in this case, I believe that's what I called it, outside. Yes, it was. So it puts in this cycle 62. So that just says preparatorily, hey, wherever this outside contour exists, and this could be outside in a subprogram call, it could be under the M30s, it's just saying get ready to use it. Doesn't know how to use it yet. I still have to go in and put a cycle associated with it. So in this case, I'm going to do path mill. Now, RP, retract plane. We're used to that being up in the header. So now when you're doing the cycles, there's a couple things that you're going to see change. I don't have any tool stuff because that was done independent. My safety distance and my retract planes are done here. And then everything else is identical between the two cycles. So we've really strived to get each of our CAN cycles as close to being the exact same format, feel, functionality between ShopMill and the G-code side of the control. The beauty is if you learn it in one area, you can immediately apply it in the other area instead of having to completely relearn your cycles. So in this case, we have our cycle 62, called up our contour, cycle 72, executed the contour. If we wanted to simulate it real quick, I'm always a big fan of simulating as I go, just to make sure I didn't make any typographical errors. And there I see my profile. Now you'll notice here, I just have a profile. And the profile is only coming up right now because I have my show path function on. If I didn't even have the show path, I wouldn't see anything, just the tool moving around. Now, why is that? Because there's nothing describing currently what the blank is for simulation. So in GCode, you have two options. In simulation, I have a button, if I hit my vertical soft key, the double arrow button, called blank, and I can come in and I could define this block right here, and it would give me some kind of blank or blob. The downfall here is whenever I come back into the program, I'm potentially going to have to redefine the blank all the time. So what I like to do is I instead like to, in the program, usually somewhere up top, insert under various, see this various button right here next to simulation, a function called blank in the upper right-hand corner. And this allows me to insert a conversational or a physical cycle that describes the blank for graphics in the GCode program. So it's the same variables, the same functions that you're used to in the header of conversational. It's just now going to insert as this workpiece call. So now you go to simulation, workpiece is called up. Around we go, machine the profile, back to a stage. So at this point, we're just going to move on a little bit, and we are going to now load our next tool and drill some holes. Pretty common, guys like to maybe move back or retract away from the part. This is one of the verbal commands I was talking about before. So in this case, I can type in Supa. Supa stands for a suppression of all work frames that are active. So it's a non-modal command. It's just saying, hey, we're going to temporarily cancel G54. Now what it doesn't do is it doesn't cancel your tool offset. So I'm going to do that by giving it a D0. But now the tool is completely canceled. So if I need to reuse it again, I do need to reload it with a D1 statement. And then I'm just going to make sure that I'm in a rapid mode. And now I'm basically positioning based on the machine coordinate system. So if I'm telling it Z0, you better be sure that that machine you're on has positioned the machine Z0 at the extent of the head travel all the way up. Some guys like to set it on the face of the gauge line to the top of maybe their platter. Well, now a Supa D0, G0, Z0 just brought the spindle touching the platter. So you will have to be aware of the machine you're on when you're leveraging this command. But now the system will have retracted. I can use this for staging the table at the end of a program. You know, maybe I wanted to shut my spindle off before my retract and my coolant. I don't need the zeros before the M9s. I can put them. It's really kind of up to you. We're going to do our next tool change. So here, I'm going to go back to Edit, go to my Select Tool function. We're going to go grab our drill. Puts our drill in, give it a spindle speed, whatever I'm running this one at. Maybe I'm running it clockwise. Sure, we're going to run coolant. Maybe I want to do feed per rev, G95 for feed per rev, and whatever I want to run my, oops, that's kind of fast, say 5 thou per rev for my drill. All right, I'm just going to move my light down a little bit. Now you notice I have no sequence numbers. I can add them later. I can have the system set up to automatically put them in. That's kind of up to you. So we're going to go and enable a drilling cycle. We're going to go down to drilling here. Pick a drilling cycle. Fill out the page. So retract, safety distance like you've seen before. Position pattern is new to you, or single position. Basically the difference is, do you want to do multiple holes or do you want to just drill a hole wherever it's sitting? So usually you want to do multiple holes. You want to use this mcall statement. From there, top of the part that I'm drilling from, do I compensate for the tip or not? What's the depth? All I have to do is go down 750 because that's my blank thickness. And then do I want to dwell at each hole? Hit accept, and the cycle is now active. It's like any other drilling cycle and any other control. It's a modal command. Once it's active, it's going to stay active until you cancel it. Now, how do I do my locations? Well, we have a position screen like you saw before. So I could use this position screen to build up the locations, or If you want to do it a little more old school, I can absolutely just do some simple rapids. So x 625, y minus point, oops, typo, 625, and we're rapid modal, so I don't have to keep putting it. I'm going to do an x 2.125 over, just to show you guys a little different scenario. Now I'm going to go to an x of 1.5, a y of minus 2.375 or 2 3/8, and then a final x over 3 inches. So same basic coordinates we did before. When I'm done drilling, whether I use the position screen or I just use discrete coordinates for drilling, to shut it off, I have to do an M call. Or a lot of us might be used to maybe a G80 statement. In our world, it's just M call. That disables my modal drilling call. From here, maybe I want to shut my spindle off, shut my coolant off. Maybe we'll do our Supa statement again. The order of the D0, D0 doesn't really matter. Supa is a non-modal statement, so if I want to do it a second time, I do need to tell it. I'm just going to stage my table somewhere. Obviously, I would want to be aware of where my machine zero is before I put these coordinates. Okay, so if we go to simulate, now we're going to get the chance to see that methodized. So we come around, we profile the part, and we pop a couple holes in my part. So you see there's certainly plenty of similarities, especially when you get to different CAN cycles. And we try to keep everything as common as we can. You'll notice it's the exact same graphics, so you don't have to learn any graphics. If I'm going to run a program, I'm going to the same exact auto mode. It's going to execute all the same. Certainly the difference is here, as I'm running it, I'm seeing the G-code automatically come flying by. I can bring up a basic blocks if I want to see the results of a CAN cycle. So I still have the basic blocks functionality. Now, when you go to start in the middle of a program, one of the main differences here is, certainly I can come pick a point where I want to start from. Maybe I want to start from this location. I'm going to use block search. This is the same as conversational, but I now have a block search mode button that you don't normally see in conversational. And what that does is that allows us to decide whether we want to use calculations or not. Calculations is saying, hey, do I want to scan to this point and set up any modal commands that happen prior to the point you're asking me to start from? If you got a really long program, you're starting from a safe point anyway. Sometimes it pays to just do without calculations. That would be what we would consider a dumb start. So you better make sure that your work coordinates are loaded, all your tool offsets, spindle, that's all there without calculations. So you do with, it's going to scan to the point. Now there is without and with approach. When you do with approach, the system will even look at the lines prior to that point if it's going to try to figure out a lead in and at least set up itself a little better. Normally, I'm always starting from a safe point anyway, so I usually do without approach. So you just make sure you have the block search mode the way you want it. Click Start Search. The system will scan to it, and now from here it's identical. Cycle start twice. Starts from that point, continues running. Other than that, auto mode, whether it be in G-code or in conversational, are the same. I do have a simultaneous record if you happen to have that option, and that gives us concurrent graphics. Here I see that I would have clipped my part, and that was because I already left my tool sitting down when I went to start it, and I didn't have a clear statement. But you kind of get the gist of it. This is all being driven certainly by my overrides. This would be real time. So like if I was to have started this all from the very beginning, then I don't see my big gouge through my part. Okay. Good. So what we want to do now is we want to now take a look at the CAM side. Oops, sorry guys. I just wanted to minimize that. And we're going to. So the next step is we want to look at a program, same exact shape, that was posted out of a CAM system. Show you kind of some very typical profiles. And then we're going to go and we're going to look at maybe even editing it, adding some functionality. Then we'll come in, we'll simulate it. We can look at auto mode too. Certainly auto mode from the CAM side to what we just saw is going to be identical. Okay. So when we go back, now what I did here was I already have that program methodized right here, and this is what I call my original. So what we're going to do is we're going to be editing this. Now, if you want to rename a file, it's pretty simple. You just hit your double arrow key over, and you go to your Properties function. Under Properties, I can change the name. Just remember to keep the .mpf extension. So I'm calling this sample 3, which is my CAM sample. So that just renamed it. I can open it up by hitting my blue arrow to the right, just like I would any of my files. And this would be very typical of how I would see a Siemens posted program. So we see the semicolons for my comments. We see some setup stuff. Now in this case, I notice that my tool is being called up as a tool 1. So we're going to have to actually build a tool in the tooltip called tool 1. Same scenario. If I scroll down, right here you'll see it. My next tool is a tool 2. So I saw both in my header, so I know what tools I need. I need an 1 1/4 and a 1/4 inch tool. So we'll go build a couple quick tools. So I'll jump over to the offset table, and these are the same tools we'll then be using in the next example on the ISO side. So we'll build up an end mill. Simply call it number 1. So if I'm going to call up a tool by just saying a T1, T2, T3, just call it the number 1 in the name. We don't need the H offset yet because that only comes into play with ISO. I'll give it a simple offset, and I do want to give it a diameter, especially if I'm using cutter compensation and the system hasn't been comping for the diameter of the tool. Some number of flutes. We'll load this up. Sure, number 12, that's fine. And since we're here, we might as well build the drill too. So now we're going to create a twist drill, and the twist drill is going to be called number 2. Now, of course, the downfall with this is I don't have the ability of putting any notes or anything in the tool itself, because the only mechanism you have is in the name. So I will now have to remember that this is a 1/4 inch drill. Okay. Load it up. So they are now both in my tool changer magazine. If I go back over to my program by hitting my shortcut key called Program, puts me back to the last edited program, I can now start to simulate. Now, before I move any further, if I want to get a quick snapshot of what this CAM program should look like, if you hit your double arrow over while your Edit button is highlighted, you get a mold maker view. And this is going to give you a quick little wireframe of whatever the job you're looking at is. So this, if you get into surfaces, it gives you a nice quick snapshot of what that surface might look like. It gives you an idea if you're looking at the right program. Certainly we could go into simulation, and we could start to simulate the part. So here I would see my cutter rolling around, make sure my show path's on, because I don't have a block form. I'll zoom out just a little bit. So that would be certainly how I would start to see my cutter path without my blank. But as we just saw before, I can either go into my blank and predefine it here, or we can start to add functionality in the program with our cycles. So don't be afraid of inserting the blank right into the part program. It retained the values that I plugged in before, so I can just hit accept, and you see how it drops in just like it would have if I was writing the program from scratch from before. So here you'll see. Now, obviously, this is a longhand program. It's not using any CAM cycles for its profiling, which would be pretty traditional for what I would see out of a CAM system. Now, one of the things I did want to show you guys, even working with CAM, it's pretty common. Maybe that I don't like the depths of these holes. Let's say, like I noticed I'm not breaking through. Well, as long as your post is posting with our CAM cycles, which in this case it is. See, there's my M call. This cycle was posted out of the CAM system. But since it's our cycle, it's still 100% editable conversationally. So here, I can come over. I can say, hey, I'm going to go with my tip, but I want to move down to -0.875, let's say. Accept it. I just updated the CAM cycle. So even though you're coming out of the CAM system, you can actually edit the programs conversationally depending on what cycles are being leveraged. So now you see we do a quick little editing change. roll around the part. Now we're breaking through. Okay. Now the other trick I wanted to show you, or another method, not even trick I wanted to show you, is let's say this was the job you were sent down, and now you wanted to add a new operation. Maybe I looked at this and I said, you know what, I want to center drill those holes before I drill them, but I don't want to have to worry about getting my CAM department involved or doing all the steps it would traditionally take to add it. Well, what you can do is not only could I start certainly inserting code longhand into this program, but what I could also do is I could find a point at where I maybe want to do the center drill, but call it up as a subprogram. Now, the subprogram could be treated either as a conversational file or a G-code. It doesn't matter. And it can be written as a main program file or in the subprograms directory, either one. We allow you to treat any program as a subprogram. So I am going to create a quick little subprogram for you that center drills those holes and insert them into the middle of that CAM file with a subprogram call. So let's talk about or get into that. So under my part program section, I'm going to do a new program. I'm not doing anything special other than just picking out as a conversational or G-code. It can be either one. I'm just going to do it in G-code for now. And I'm going to call this subprogram center. So I type in a name, select OK. It launches my basic program. Now, since I know I'm using this as a subprogram, may or may not want to do a bunch of protocols as far as my safe start header lines and whatnot, especially like a work coordinate. I wouldn't want to switch my work coordinate midstream. I could certainly do like an absolute or an inch mode because I'm certainly intending this portion to be run that way. So be careful what you do. Last thing I want to do is bury a work coordinate shift in here. You may or may not want to do a tool change here. In this example, it's easier to do the tool change here. So I'm going to do that. So we're going to go. Now, I happen to have a center drill already created in my tool table, so I'm going to use it. So even though I'm using my numerical T-calls, it doesn't matter. I can intermix them in the same program, in the subprogram. It's OK. Some feed rate. So we'll do 10 inches a minute. Let's fire up my spindle. So we'll say we're going to use 1,000 RPM. Maybe I want my coolant on. All right. Now we're going to drill some holes. So I'll go over to drilling. Now I'm center drilling, so I'm going to use our center drilling cycle, which is a cycle 81. And I can tell it my plane if I want, my safety distances. Now what I like about using this cycle 81 or the center drill cycle is my depth can be either based on tip or diameter. It's diameter of my spot face. When I built that center drill, I did tell it the included angle of the drill, just like you do before the center drill. So in this case, it's a 90-degree spot drill. So I can say, hey, I want to spot it to 325 because I know I'm drilling a 1/4-inch hole. I should get a nice chamfer without kind of having to guess here. So fill out the cycle, hit accept. There I have my quick cycle. I could do my rapid positions like I had before. I can use the position screen. I'm just going to use that one in this case because the hole's already there. I'm kind of cheating. If I know that I'm going to be done, maybe I want to shut my coolant off, shut my spindle off. I could certainly use a Supa here if I wanted to. Get the tool up out of the way. Now you do have to remember to give it an M30 or an end of program. If you're building this as a sub-program in the STF area, it would be an M17, which is an end of sub-call. Okay, so we got a quick little program to spot drill those holes. So if we come out, go into our CAM sample, find the area where I want to call up this program. So I want to come down here and probably after my optional stop before my next tool, I'm going to just make a little bit of space here. And now we're going to insert the call. And there's all kinds of elaborate calls you can do within the Siemens control, especially if the subprogram resides outside of internal memory. But you can do something as simple as literally just type the name of that file. I don't even need the extension, just in this case, center. Once I do that, that will actually look in its program structure under NC and see if it can find a file with the name center. If it can, it'll execute it. Just be careful that I don't have multiple programs with the same name in different subfolders. It's always going to look at wherever the main program is first, but you obviously run some hazard of it grabbing the wrong file. But it's as simple as that. So a quick little call to center. You can do a call statement, C-A-L-L, space in the name, but it's not even needed. Tool offset, no tool offset active, right. Let's just edit this program real quick. Why would I not have a tool offset active? It's right there. Let me just cancel this. And there we go, spot drill, and we drill our holes. So certainly the mechanism of using really anything as a subprogram can really allow you to add functionality, modify functionality, even on elaborate posted programs, pretty quick and easy. And again, remember that entire example, that could have been 100% a conversational routine as opposed to GCode. So even if you're a guy that's using the machine conversationally, but every now and then gets GCode programs fed in, you can add the same kind of functionality. So it's as simple as just giving it the name of the file right there, center. Okay, so if I was going to run the part, obviously the next step would be jump over to execute. Works the exact same way as you saw before. I can bring up my simultaneous record. If I want to have my graphics, now it's fully interactive. It's being driven by my feed rate override because she's running real time. So in this scenario, the machine physically would be drilling those holes. Okay. So I'm going to back out of here. We're going to take a look at our final scenario, which is the ISO mode. And for lack of a better term, we like to call it our FANUC compatible mode. Really, it was designed to be able to allow a consumer that has large, maybe libraries of part programs that were methodized for a FANUC style control, the ability of still leveraging them within the Siemens control. So one of the big things that you're going to see here when we take the program that was a core ISO style program and modify it to work in our world is this G291 statement. So G291 activates ISO mode. From there, anything after that can be in straight ISO protocol. So we are going to have to do a slight modification in the tool. So you guys are going to get a chance to see that. We can start to add functionality to even use Siemens functions within that mode. So you're going to get a chance to see that. You'll see how we can still simulate it in wireframe, but still even leveraging the full graphics. So you have a lot of capabilities even in that mode. There are things that are a little bit more restrictive because we do have to comply with the way that ISO program is written. So you are maybe losing some advanced functionality, so you do want to be careful with it in certain areas. But absolutely, especially for standard 3-axis programs or 2-axis lathe programs, it's a great solution. And then we can go in, show you how it runs. It's going to look and run and feel like it would have always felt in maybe a comparable control from another vendor. Okay, so without further ado, let's talk a little bit about ISO mode. So at this point, if I go back to Program Manager, we notice I had an original program. So I'm just going to rename it, get rid of the original, just for my own reference. So this is going to be sample 4. So we open up the program, and this would look like your traditional. So you have the comments, / for block skips. This would be your traditional ISO style G-code program. G28 reference returns, G91, G28. Here's our critical statement right here. There's our G43 call for calling up our tool length offset. You don't have to do that in Siemens control. Also your decall for calling up the diameter of the cutter. Well, when you're running in the ISO mode, you have to comply with all these. Same scenario when we get further down. This one's using cutter comp, walking around the profile of that part, but we're going to even get to drilling. You're going to see there's your standard G81, your Z, your R, IJKs, depending on the cycle you're in. A lot of times when somebody asks, what cycles are going to work in this mode, general rule of thumb, anything G99 and lower will typically work. We have entire manuals written just for ISO mode that will give you all of the real detailed description of each and every cycle, how they have to be protocoled. From a lathe side, we do support the 3 different protocols in FANUC, A, B, and C. But you do have to set up a parameter in the control to comply with either one of those protocols. I think our default is usually B, if memory serves me. But you can even support those 3 protocols. Okay. What has to change? Well, this right now won't run. So if I were to simulate it currently without doing anything, it's going to kick back. In this case, it's giving me syntax alarms because it doesn't like these parenthesis statements. So first thing we got to do, if you have percent signs, get rid of them. If you have a program number, the O and the 4-digit number, get rid of it. We don't want to see that. And just prior to whatever I'm doing, I want to type G291. That's going to trigger ISO mode. Now, to get back into the Siemens mode, it's a G290. You don't have to do it at the end, but I usually teach guys to get in the habit of it. Most builders will automatically reinitiate G290 at the end of an M30, but you're still assuming that based on how the builder built the machine. If you put a G290, you're certainly not going to hurt yourself. This way you know it's switching back to Siemens protocol. So G290 is Siemens, G291 is ISO. Okay, so simply by just adding the G291 at the very top, I should now start to have a program that is going to work in an ISO format. All right, so I had mentioned this earlier and I forgot to do it. H number 1 is not defined. So right now the system's telling me, hey, you're calling up H1, but there is no H1. Well, that is because once you get to ISO programs, you have to start using this H column. In the H column, I'm going to put the number of, or the name of the tool. So in this case, tool 2 is my drill, so I need an H tool. That H will also correlate to the D number as well. So you have the name of the tool you want to be associated with here as well as in the H column. So 1 and 1, 2 and 2. This is very important. It's the only time you ever use this column. It's also a quick way for you to know if your control supports this ISO mode. It's not an option within Siemens, but it's up to the builder if they want to commission the machine that way or set up the control that way. If you do not have an H column, your system does not support ISO, and everything we're talking about now cannot be done. It could be turned on, but you would have to put a request in through the OEM on that. So now by adding my H values here, I can simply go back into the program, simulate it, and if I haven't missed any other scenarios, look at that. We got a basic program. So our simple lead in, lead out. Now, I have no graphics as far as solid modeling. I'm just seeing wireframe because there's no blank. I can go into the blank area and fill it out and start to simulate that way. But you can also insert the blank here. Now, on the older systems prior to Operate, which is what we're running now, our current system, you had to be very careful with the Siemens cycles had to be done, initiated outside of your 291 mode. Now we're allowing you to start to intermix some of the cycles. So here I can have the workpiece after my 291, and I can simulate it, and you're going to see it's still going to work. So here, blank comes up. It didn't give me any alarms. Before it would have given you an alarm. You had to solely do what could have been done in the ISO mode. So things like, I want to run high speed. So I want to insert a high-speed function into it. Before, that always had to be initiated outside of it. So you can start to intermix. I would be careful, certainly if you're getting to a lot of instructions. So like, maybe I want to add the center drill function like we did before. Well, if you want to do it in the Siemens code, I would switch to our code and then switch back. So like to give you an example of that, let's say down here, there's my drilling, here's my tool 2. So maybe just prior to this, maybe down here, I want to center drill. I want to add in some lines of code. Now, one thing I got to be careful with is putting the machine back to absolute mode because they were doing a reference return in incremental, and this post didn't actually put it back to absolute until after the tool change, which is a little scary, but that's okay. So right now I can midstream switch to G290, and now, like you saw earlier, I can open up, maybe I'm going to open up this little center program, and I'm going to copy all this. All right. And let's just grab this. And this is going to be everything I want to put in there. Copy it. Paste it. All right. And let us close that. I don't need it up. So I'm switching midstream back to Siemens mode, switching back to ISO mode when I'm done. So now you can start to see how you can intermix our standard core functionality even in a program that was maybe methodized. No tool offset active. Let me see why that is. D1. Let me just get rid of that real quick. All right. All right, there we go. Oh. On the subroutine. M62. That's a little funny. But so now you can start to see how we can start to intermix between the two styles or the two types of protocols. So G290, G291, and then we can continue on within that. Okay, now from a running standpoint, certainly I can, let me just start to show you what that would look like. I'm just going to take that out right now for what we were editing. All right, so if I was going to be running a straight, all right, that should be there. Put it back to the way it was real fast, just so you see. All right, so we roll around, we're running the straight program. So just to show you, we're going to next go over to our auto cycle. So here, we put the highlight at the top, hit execute, and when we're running, and I'll just slow down my override so you can see it, so it's not going too fast, it's just sitting in that straight code. If you were to look at all active G codes, you now see G291, and you see that all of these preparatory codes match your ISO protocol. Okay. If the system has simultaneous record functionality, as long as you got the blank set up there, you can start to use it. Obviously, my tool was down when I started, but you can start to see. So any of the same features, any of the same functions. The old system used to have to watch out when you were starting in the middle. You had to use what we call without calculations block search. You should be able to do it now with calculations, and it should set it up. So see, it's going to need tool 1. So let's see if it does the tool change. There you go. Looks like it didn't catch the radius. So you do want to be careful. This is kind of the scenario I was talking about. You want to be a little careful when you're in ISO mode. There are things that start to get restricted when you're working within this mode. You have to be a little bit safer. But absolutely, you can certainly start to use it to utilize maybe existing programs. What I wouldn't do is I certainly wouldn't use this as a shortcut to get a post for my machine. If you're going to develop a post, develop within the Siemens protocol and use all of our functionality. But if you've got libraries of stuff already created, G291 is kind of the way to go. Okay. So with that being said, we are going to open up for maybe any questions that have arisen. I did see, I got one question. Can Siemens PLM AEs get access to SINUTRAIN virtual controller? Absolutely. Actually, a couple years back, I did an entire series for a bunch of the PLM AEs, and we had donated quite a few versions of SINUTRAIN. What you can do, if you go to our website, which earlier, let me go back to it. I'll put it on the screen again. You can at least get a trial version. So if you go to the usa.siemens.com/CNC for you, under there you'll see there's a link for documentation and downloads. And once you go to documentation and downloads, you'll see a link for SINUTRAIN. If you do that, you can download a 60-day trial, get that all working. If you see value in it, let us know, and we can try to line you up with a fully licensed copy. The software itself is a traditional charge, especially if you want to leverage it to maybe end users. There would be a charge for the software. We also will give you packages if you come in and do some training classes. We do host training classes at our Chicago Elk Grove facility, specific for OEMs, importers, and dealers. They're free of charge. And if you get a chance to attend those, you can get a free version of SINUTRAIN as well. With that being said, if you have any further questions regarding the SINUTRAIN, as far as our classes at Elk Grove, just reach out to me. I'd be happy to give you some information. Okay, so if anybody has any questions, I'm going to start to go through these. So let me take a look here. Well, here's a question. In ShopMill programming, can we do a reference return like the Supa command in GCode? So to answer that question, we'll answer it with an example. Absolutely. So I mentioned it briefly earlier, but in any programs you write in conversational, you can actually intermix GCode and conversational. So let's say, for argument's sake, at the end of this program, I wanted to do a Supa retract. Simply hit the input key, the yellow input key. I use the enter on my keyboard. I cheated. And now you can start to type out GCode instructional statements. So Supa, D0, G0, Z0, and there you go. Any GCode instructions can be done anywhere within the part program just by hitting the input key. So you can intermix GCode and conversational within the system. Okay, let's see. We got a few more that came up here. Let me expand it up. Do you record the seminars? Where can you view it? Okay, everybody that's here on the session, I said it earlier, you might have come in a little later, but not a problem. You will automatically get sent out a link to view the recording. I will do my best to see if I can get it out this afternoon before the end of the business today. From there, back on that web page I was just showing you, all webinars or seminars get posted on this website, the CNC website, for later viewing as well. So if it's something that was maybe done a couple months ago, a year ago, you can always come to this page. Feel free to refer people to it if you have maybe you're a dealer and you have an end user that you want to kind of get up to speed before you go in there and try to train them. You want to let them at least see a couple videos and kind of get on it a little bit. By all means, you can take a look. Can we leave the H number in the H column even when switching back from ISO to? Absolutely. Yeah, the H number will never be looked at unless I'm in ISO mode. So whether it's there or not doesn't make any difference. So absolutely. Let's see, what else do we have? When posting from CAM, can you use cutter compensation for adjusting wear of an end mill? Most certainly. The example I gave you, and I showed just before here, that one was posted with cutter compensation. So if we look down, we see, I believe it was. Let me find it. No, this one wasn't done. So this one was posted without. If you post it with cutter comp, absolutely. The only thing you got to be careful of when you start to use cutter comp is if the CAM system's taking into account the diameter of the cutter, and then you got a G41 and you're putting the full tool diameter here, it'll double comp it. So you got a couple options. If you zero out the cutter comp here, you're not going to be able to get the full solid modeling to work properly because we'd have no diameter of the cutter, so the graphics will look a little funny. You can certainly still use the wireframe portion of the graphics, or there are ways to actually, there's instructional commands you could use to tell it to negate the fact that there's a diameter in the tool table. But normally most people, when they're doing wear, you would just leave the diameter at 0 or put some small incremental values in here. All right, let me see, what else do we have? Is it possible for my CAM system to output the block form or the blank? Yes, absolutely. So I've already been getting a lot of the master CAM guys to output it. So this protocol right here, this work piece. Now they will have to work within our restrictions. So it's going to have to be either a block or a cylinder or a pipe, or some form of hex stock. We can't take like any irregular shapes and stuff like that. But as long as they can comply, and let's face it, most of those guys are just using a basic block anyway. Yeah, absolutely. I get a lot of the guys that are starting to leverage that right out of the posted program. Okay. Here's one. Can I use ISO mode for 5-axis programming? Okay. That's an area that I would start to enter with caution. Once you get to 5-axis, you have a lot of advanced cycles potentially being leveraged. In our world, Traori, which is your rotary tool point compensation, Cycle 800, which is your rotary workpiece compensation, OriVect, OriAxis. I mean, all sorts of commands that are very critical when you get to 5-axis cutter path. And the problem is when you start to look at competitors' controls, they have all kinds of different variants of their own commands. So although the base program would read, if you had a direct axis program positioning A and C, it would work. But potentially you're going to run into probably a lot more pain. So we don't necessarily recommend running 5-axis programs in ISO mode. We suggest if you're going to get into that technology of a machine that you methodize a post out so it can run in the Siemens world. The other thing is, this is kind of our world. When you get to 5-axis or mixed technology, mills that do turning or lathes that do milling, this is where Siemens really starts to shine. This is why you would want to buy a Siemens control, because this is our world. We live in this world. So with that being said, if you try to start running the system in an ISO mode, potentially you can give yourself a lot of pain, and you're not taking advantage of all the functions that are there. So be careful. Okay, looks like we got one more question here. Where can we get more about the wear comp workaround to make the graphics work with the 0 diameter column? You know what we can do, Mike? We could take this offline if you'd like. I could show you a little more detail. Basically, what you would do is there's a statement. I'm trying to see if I have an example that I could show you real quick. I don't think so. But there is a instructional statement, TOFFR, that I think it's just OFFR. That allows me to modify the diameter on the fly. I'm just looking to see if I maybe have a program that I can show you handy real quick that has it in it. Where am I? Do I have it here? No. I tell you what, if you would like to maybe shoot me an email when we're all said and done, we can certainly, I can certainly get you the exact instructional statement, and you can kind of play around with it. I am going to just respond back to your question, just in case you don't have my email. Okay. As well, it was also in the beginning of the presentation. Shoot me an email. This way I'll have yours, Mike, and then I can get you the exact instruction and even kind of break it out of a program so you could see how you could apply that. Okay. Let me see. Do we have anything else? Mark P. at CV Tool also would like that. Mark, I know you definitely have my email. Shoot me an email as well, and I'll send it to you as the same as sending it out to Mike. This way each of you can see it. It's a pretty common scenario. I know guys want to use the 3D graphics, but it's already outputting the radiuses. So absolutely, send that out. Okay, so it looks like we're right at the end. We certainly used all of our hour-and-a-half session. So let me stop our recording now.